Good day, viewers. Good day, viewers. I welcome you into class today. We are still on our series, Solution to System of Linear Equations. We started this series some time ago. We have looked at several methods of solution to system of linear equations. Today, we shall be looking at another method known as the Choleski's algorithm. The Choleski's algorithm. This particular method of solution is a direct method of solution. Remember, I told us at the beginning of this video, or at the beginning of this series, that we have two major methods of solution. We have the direct methods of solution, and we also have the iterative methods of solution. When the series started, we considered the matrix inversion method. We also looked at the Gaussian elimination method. We looked at the simple elimination method. We also considered the simple substitution method. We considered the Cramer's rule, and today we are looking at the Choleski's algorithm. All these methods, this should be the sixth direct method. All these methods we have been considering since the series started are all direct methods of solution. In our next video, we shall be looking at the iterative methods. We shall be ending the direct methods of solution today by using the Choleski's algorithm to solve a system of linear equations. Once again, beloved, my name is Dr. Chris Esekaibe. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. I live in Nigeria. I work in Nigeria. I'm a proud Nigerian. I hold a doctorate degree in mathematics with distinction, a master's degree in mathematics, and a bachelor degree in statistics. I'm a specialist in numerical analysis, data analysis and modeling, scientific computing, statistical analysis, and mathematical research. I also have scholarly publications in renowned publications, and also have presented papers in renowned conferences within and outside Nigeria. I am a member, an active member of the Nigerian Mathematical Society, and also a member of the Nigerian Statistical Association. Why not? If you are an AI firm, you work with mathematicians or statisticians to train AI or LL model, that's large language models. Why not? You can contact me to be part of what your team of mathematicians and statisticians are doing across the globe. My contacts are +234 803302193. This first contact here is for WhatsApp and for call. Then my second contact is +234 7066297535. This second contact is only for call, not for WhatsApp. Then my email address is chrisdavis2015@gmail.com. Why not? I'll be looking forward to hearing from you. It will be an awesome experience. If you are also a research institute, you do a lot of research, statistical research, mathematical research, you can consult me to be part of what your team or your firm is doing. Or if you are a research student, an MSc student in mathematics and numerical analysis, you can also consult me to be part of your research work. I will be looking forward to hearing from you. God bless you. So we shall be going into the business of today. We are rounding up the series in our next video, not this video. The next video we shall be looking at two iterative methods, the Jacobi and the Gauss-Seidel methods, or iterative methods for solving system of linear equations. This is the sixth direct method we are considering in this series, the Choleski's algorithm. Permit me to clean this part of the board so that we can progress with the business of the day. Please, once again, let me remind you, this is Dr. Chris Esekaibe, the owner of the YouTube channel Dr. Chris Esekaibe. The essence of the channel is to share knowledge across the globe on key topics in statistics and mathematics, preferably numerical analysis and statistical analysis. If you have not subscribed to my YouTube channel, please subscribe to my YouTube channel. Click on the notification button, that is the bell button, so that anytime I upload a new video, you will be among those that will get a notification. Share my videos in your social media platforms, like the videos, and as you do, God will bless you richly. The essence is to share knowledge across the globe. So be part of those sharing knowledge across the globe. So the Choleski's algorithm is a direct method of solution for solving system of linear equations. You can remember since the series started, we have been solving one particular system of linear equations, a 3x3 system, where we get our x1 to be equal to 1, our x2 to be equal to 2, and our x3 to be equal to 3. That particular system is consistent, is unique. A system of linear equations is said to be consistent and unique if it has only one set of solutions. No matter the method used in solving that particular system, you arrive at the same set of solution. But when you use a particular method and you arrive at a different set of solutions, such a system is inconsistent, it's not unique, and is dependent. So today we shall be using the Choleski's algorithm to solve that same system we have been solving. We have used 5 different methods: the matrix inversion method, the Gaussian elimination method, the simple elimination method, the simple substitution method, and the Cramer's rule. Those 5 methods were used to solve that same problem, and we arrived at the same set of solutions. Today we shall be using the Choleski's algorithm to solve that same problem and see if the solution will violate the consistency of the system, or the uniqueness of the system, or the independence of the system. The Choleski's algorithm involves just 3 simple steps. 3 simple steps. Step 1. Of course, definitely when you have a system of linear equations, the matrix A, which is a square matrix, will form the coefficients of the unknown on the left hand side of the equation. You bring the matrix A out, it can be written out, and every system of linear equations can be put in matrix format, that is AX equals B. This is the matrix format of every system of linear equations. B is a column vector, X is the vector of unknowns, while A is a matrix. I told you if you see 2 bars under a capital letter, it means that capital letter is a matrix. We represent matrices with capital letters. The first bar is for the rows, the second bar is for the column. When you see a bar under a capital letter, it means a vector. A vector is a special kind of matrix that can have either 1 row or 1 column. So this one is X is a column vector, B is the right hand side, and it's also a column vector. So this is the matrix format of a system of linear equations. So A here is a matrix. It's a square matrix. It's a square matrix. So for you to successfully use the matrix approach or any method that involves the use of any part of matrices, then A must be a non-singular matrix. A non-singular matrix is a matrix whose determinant is not equal to 0. Now, the 3 steps involved for using the Choleski's algorithm are: step number 1, decompose A into a lower and upper diagonal matrix. You will form a lower triangular matrix and an upper diagonal matrix. This is what it means. L means this is A from the system. This is L, the lower triangular matrix, while U is an upper diagonal matrix. Now these are, of course, for a 3x3 system we are going to be considering today. This is the matrix A, A11, A12, A13, A21, A22, like that, A31, A32, A33 is equal to, this is the lower triangular matrix. You can see the upper part of it, the elements above the main diagonal will be 0. That's how you know a lower triangular matrix. You can see 0, 0, 0, 0. These are the elements on the main diagonal L11, L22, L33. So every other element above the main diagonal will be 0. So it forms a lower triangular matrix. Then U is an upper diagonal. The diagonal element or the element in the main diagonal will be 1. It can be a 4x4 system, it can be a 5x5 system, it can be a 7x7 system, an 8x8 system, a 10x10 system. So the element, when you are writing the U is an upper diagonal matrix, meaning that all the elements in the main diagonal will be 1. Then you can see other elements above, while the one below the main diagonal will be 0. So that is how you have that. Then this step 2, you will now compute Y. Y is also a vector of unknowns using this formula L. After you have gotten the lower triangular matrix L, you use to multiply Y and you equate it with the right hand side. Then you are now going to use a back substitution to get values for Y. Then step 3, you are now going to compute the main unknown X. That's the last step. You compute X, which is the main unknown, using U. U is now the upper diagonal matrix. Note, when you're writing the upper diagonal matrix, the elements on the main diagonal will be 1, 1, 1, 1. Then other elements above it, then the element below the main diagonal will be 0. So you can see you're now using U to multiply X. X is now the unknown we are looking for. Then you now equate it to Y. Y is the set of vector, or is the vector, the column vector gotten from step 2. So now we are going to practicalize this, using this to solve the same problem we have been looking at. Just follow me as I run through these 3 steps in solving that particular problem, and you'll be glad you did. Now, permit me to write out the particular problem so that we can start right away. Now, the system of linear equation is 3x1 plus 3x2 plus 5x3 is equal to 24. 3x1 plus 5x2 plus 9x3 is equal to 40. 5x1 plus 9x2 plus 17x3 is equal to 74. So this is the system we have been solving. Now, the first thing we are going to do is to bring out our A. So from here, this implies that A will be equal to 3. You write out the coefficients of the unknowns. 3, 3, 5, 3, 5, 9, 5, 9, and 17. So this will be our matrix A. So step 1 says we should decompose A into an upper or a lower triangular matrix and an upper diagonal matrix. So permit me to see how this can go. Right now, I want to first of all clean these parts and of course the system. I'll clean the parts and clean the system. So we'll come here. We'll now have our A is 3. So I want to write this A is equals to LU. So our A is 3, 3, 5, 3, 5, 9, then 5, 9, 17 from the system. Then, of course, this will now be equal to LU. Look at our L. Our L is L1100, L21, L22, 0, L31, L32, L33. Then you have it like this. Then our U is 1, U12, U13, 0, 1, U23. Then we have 0, 0, 1. This is what we have here. So we come here now. Our A is 3, 3, 5, 3, 5, 9, 5, 9, 17. Now, to decompose this so that we can get values for L11, L21, L22, L31, and so on and so forth, we are going to carry out what we call matrix multiplication. Now, let me throw a little light on matrix multiplication. The two matrices are compatible for multiplication if the number of columns in the first matrix is equal to the number of rows in the second matrix. I give you an example. If I have a 3 by 4 matrix multiplying a 4 by 5 matrix, for instance, this is the number of columns in the first matrix. You can call this matrix A, you can call this matrix B. Then this is the number of rows in the second. This one is the column, this one is the row, this one is the row, this one is the column. The number of columns in the first matrix must be equal to the number of rows in the second matrix. The number of columns here is 4, the number of rows here is 4. So the two matrices A and B are compatible for multiplication. Now, if you now multiply A dot B, you are expected to get this result. So you are going to have a 3 by 5 matrix. That is a 3 by 5 matrix. That's what you are going to get. I give another example. If I have a matrix A, maybe A is a 3 by 2 matrix, and B, I want to multiply by B, and B is a 2 by 6 matrix. Now, this is the number of rows in A, the number of columns in A, this is the number of rows in B, the number of columns in B. Now, for A and B to be compatible for multiplication, the number of columns in A, which is 2, must be equal to the number of columns, must be equal to the number of rows in B. So you can see now they are compatible. The result now, A dot B will be equal to 3. The answer you are going to get will be a 3 by 6 matrix. Like this, it will go like this. You are going to get a 3 by 6 matrix. If I have A again, and I have B, I have this to be 4 by 5 matrix, and this to be 3 by 4 matrix. This is the number of rows in the first, the matrix A, the number of columns, number of rows, number of columns. Now you can see the number of columns in matrix A is 5. The number of rows in matrix B is 3. They are not the same. So A and B are not compatible for multiplication. So for two matrices to be compatible for multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Now look at it. We have two 3 by 3 matrices. Look at it here now. L is a 3 by 3 matrix, 3 by 3 matrix. Then we want to multiply our U. Our U is also a 3 by 3 matrix. Then you will see now the number. Look, this is the number of rows in L, the number of columns in L, the number of rows in U, the number of columns in U. Now look at it. The number of columns in L equals the number of rows in U, so they are compatible. So our resulting L dot U will be equal to, you are going to have this, is equal to a 3 by 3 matrix. That's what you are going to get. So that is how to check for compatibility when you are dealing with multiplication of matrices. Of course, addition and subtraction of matrices, you must have the same number of size matrices, that is 3 by 3 adding to a 3 by 3, or 3 by 3 a matrix subtracted. So it must be in equal dimension. But there is not, we don't have what we call division of matrices. We have addition, subtraction, and multiplication. And that is the law guiding multiplication of matrices. Instead of division of matrices, we have what we call the inverse of a matrix. Now we want to go ahead to multiply L by U. That means L and U can be multiplied, and the resulting matrix is going to be a 3 by 3 matrix. Now let's go ahead. L11 times 1, this will be L11 times 1 plus 0 times 0 plus 0 times 0. This will be L11. Then you come again. L11 times U12. L11 times U12. You come to this like this. Matrix multiplication goes like this. You are taking each and multiplying this. That's why they must be of equal number. So this times this plus this times this plus this times this. Then the second one, for me to get the second element here to be L11 times U12. This will be L11 U12 plus 0 times 1 plus 0 times 0. That is that. Then the next one, L11 times U13, it will be L11 U13 plus 0 times U23 plus 0 times 1. That is what you are going to have. Then you come to the next one. We are done using this first row. We want to use the second row. This against this, this against this, this against this. Then we'll now use the third one. This against this, this against this, this against this. Now let's use the second row against the columns in U. L11 times L21 times 1, it will be L21, then plus L22 times 0 plus 0 times 0, that is L21. Then L21 times U12, this will be L21 U12 plus L22 times 1 plus L22, then 0 times 0 is 0. Then the third one, L21 times U13, this will be L21 U13 plus L22 times U23 plus L22 U23, then 0 times 1, of course it will be 0, you don't add it. Then you come again, you are using this third one. L31 times 1, it will be L31. L31 times 1 is L31. L32 times 0, it is 0. L33 times 0, it will be 0. So you have, when you add 0 to those, to L31, you have L31. Then this to the next one. L31 times U12, you have L31 U12 plus L32 times 1 plus L32 times 1 is L32. Then L33 times 0 is 0. You have that. Then you come to the last one. L31 times U13, it will be L31 U13. Then plus the next one, plus L32 times U23 plus L32 U23, L32 U23, then plus L33 times 1, it should just be plus L33. Then this is what you are going to have. It's a 3 by 3 matrix that you are going to have. You can see now, we are not through decomposing. The main step is to decompose A into L and U. Now we have done carrying out this multiplication. Permit me to clean these 3 steps so that we can start getting values for the L's and the U's. For the L's and the U's. Permit me to clean it so that we can start getting values for the L's and the U's. Now, continuing from here, there's what we call equating elements. Write it, equating elements, comma, we have, just watch, it's very interesting. This is a 3 by 3 matrix, this is A. When L and U multiplied, we multiplied L and L by U, we got this 3 by 3 system. So you can see this is a 3 by 3 system, and this is also a 3 by 3 system. Now we want to equate the elements. Look at it here now. The first element here is L11, the first one here is 3. So by equating elements, our L11 is equal to 3. If our L11 is equal to 3, from here we can get our, then it means that our L11 U12 is equal to, you equate it, is also equal to 3. So this implies that our U12, okay, let's go. Since our L11 is 3, we are going to have 3 U12 is equal to 3. So this implies that U12 is equal to 3 over 3 is equal to 1. So you have that. Then again, you come here, L11 U13 is equal to 5. So you come here, you write it, L11 U13 is equal to 5. Now, what is our L11 is 3. That means 3 U13 is equal to 5. It means that our U13 is equal to 5 over 3. You can see the way it is going. So we are equating. Then from here again, our L21 is equal to 3. So you come here, our L21 is equal to 3. Then our L21 U12 plus L22 is equal to 5. So our L21 U12 plus L22 is equal to 5. That's the element here. Now we already have our L21. This implies that our L21 is 3. Then what our U12, we already got our U12 to be 1. U12 is 1. So this will be 3 into 1 plus L22 is equal to 5. So our L22 is equal to 5 minus 3 is equal to 2. We take note of that. Then you come here again. From here, our L21 U13 plus L22 U23 is equal to, look at it here, is equal to 9. So is equal to 9. Let me write it clearly. Is equal to 9. Now, what is our L21? Our L21 is 3. Then what is our U13? Our U13 is 5 over 3 into 5 over 3. Then plus what is our L22? Our L22 is 2 plus 2 U23. U23 is the unknown, and this is equal to 9. Now having this, you are coming here. Three, we cancel 3. So you are going to have 2U23 is equal to 9 minus 5. 3, we cancel 3. So this 5 will go to the other side, and this will be equal to 4. So this implies that U23 is equal to 4 over 2, and that is equal to 2. That is what you have there. I hope you are taking note of all this. It's as simple as that. Our U23 is equal to 2. Then again, we are not done comparing. Our L31 is equal to 5. So you come here, our L31 is equal to 5. Then this means that our L31 U12 plus L32, which is this one, is equal to 9. Is equal to 9. So from here, what is our L31? Our L31 is 5. What is our U12? Our U12 is 1. So plus L32 is equal to 9. So L32 will be equal to 9 minus 5. 5 times 1 is 5. When it goes to the other side, this will be 4. So our L32 is 4. Our L32 is 4. Then from here, this last one, we have our L31 U13 plus L32 U23 plus L33, and this is equal to 17. This is equal to 17. Now what is our L31? Our L31 is 5. So you have 5. What is our U13? Our U13 is 5 over 3 plus what is our L32? Our L32 is 4. What is our U23? Our U23 is 2. U23 is 2. Then plus L33 is equal to 17. So we are going to have our L33 is equal to 17 minus 5 times 5 is 25 minus 25 over 3. Then 4 times 2 is 8 minus, we put it 8 all over 1. So we can take our LCM to be 3. If our LCM is 3, 3 divided by 1 is 3. 3 times 17 is 51. So we are coming here, you're going to have 51 minus 3 divided 3 is 1. 1 times 25 is 25. Then 3 divided 1 is 3. 3 times 8 is 24 minus 24. So we are going to have this implies that our L31, our L33 will be equal to 51 minus 49 is 2. That will be 2 all over 3. That is what you are going to have. So beloved, you can see that we have been able to get values for the L's and for the U's. Please subscribe to my YouTube channel, Dr. Chris Isekaibe. Click on the bell button, the notification button, and share my videos in your social media platforms. Like my videos. Be part of those sharing knowledge across the globe. The essence of this YouTube channel is to share knowledge on key topics in mathematics and statistics, preferably numerical analysis and statistical analysis or computing. Now we are going to bring out these values and put them into L and U. Permit me to clean this part of the board. I hope you have been following. We are still in step 1, decomposing A into a lower triangular matrix and an upper diagonal matrix. Remember, our L is equal to L11, 0, 0, L21, L220, L31, L32, L33. Now let's put the values. So what is our L11? Our L11 is 3. Look at L11 here. Then you put your 0 and 0. Then what is our L21? Our L21 is also 3. Then what is our L22? Our L22 is 2. Then you put this 0. Then what is our L31? Our L31 is 5. Our L32 is 4. And our L33 is 2 over 3. That is the lower triangular matrix. You can see we have been able to get the values for the L11, the L21, the L22, the L31, the L32, and the L33. Now remember, our U is equal to 1, U12, U13, 0, 1, U23, 0, 0, and 1. It's an upper diagonal matrix. Diagonal in the sense that the main diagonal element will be 1 all through. So if it is a 4x4 system, a 5x5 system, the main diagonal when you are writing out your U will be 1. Now let's go ahead and write the values for the U12, the U13. This will you put your 1 here. What is our U12? Our U12 is 1. What is our U13? Our U13 is 5 over 3. Then what is the next one is 0. Then the next one is 1. What is our U23? Our U23 is 2. Then we have 0. We have 0. And the last one there is 1. You can see how simple this particular system is. Now we have been able to decompose A into L and U. This simply means if I want to write my A, my A which is 3 3, 5, 3, 5, 9, 5, 9, 17. This is my A. My A is simply going to be 3, 0, 0, 3, 2, 0, 5, 4, 2 over 3. This is L. Then our dot U, 1, 1, 5 over 3, 0, 1, 2, 0, 0, 0, 1. Beloved, if you multiply these two matrices, you will get A. This is L, the lower triangular matrix. This is U, the upper diagonal matrix. So if you multiply these two matrices, you can try it in your free time. Multiply this, you will get this. So A has been decomposed or splitted into two different matrices. That is the step 1 of the Choleski's algorithm. Now let us go to step 2. Permit me to clean all this. I hope you have taken note of how the L's and the U's were computed. So permit me to go into the next step, which is step 2. Step 2 is not tedious. Likewise, step 3. The main step that has taken our time is the step 1, decomposing A into a lower triangular matrix and an upper diagonal matrix. Now our step 2, we are to compute y using Ly is equal to B. So this goes like this. What is our L? Look at our L here. Our L, we are going to write down our L. Let me start it here. Our L will be 3, 0, 0, 3, 2, 0, 5, 4, 2 over 3. Then our Y, because the system we are solving is a 3 by 3 system. Remember, let me write the 3 by 3 system here again so that you can have the flip of the problem we are solving. Is 3x1 plus 3x2 plus 5x3 is equals to 24. 3x1 plus 5x2 plus 9x3 is equal to 40. This is a 5x1 plus 9x2 plus 17x3 is equal to 74. You can see that the problem is already at my fingertips. So now we have our A. This is A. Of course, the unknown are the x1, x2, and x3. Then the right hand side is 24, 40, and 74. Now we are introducing y. Y is also an unknown because the system is a 3 by 3 system having 3 unknowns and 3 equations. That means our y will likewise be an unknown having that is a vector having 3 unknowns. So you can call the y y1, y2, and y3. That's what we are going to put it. So we are following this formula and it's equal to our b. What is our b? Our b is the right hand side, which is 24, 40, and 74. Now, multiplying these, we have to carry out the matrix multiplication, of course. Now, this will be 3 times y1, 3y1, then plus 0 times this, 0 times will be 0, is equal to 24. Then the next one will go again, 3 times y1, 3y1 plus 2 times y2 plus 2y2. Of course, 0 times y3 will be 0. Of course, this will be equal to 40. Then the third one will be 5y1. I hope you know how to use a matrix to multiply a vector. Let me show you, look at it now. This matrix is a 3 by 3 matrix multiplying a 3 by 1 matrix. This vector here is a 3 by 1 matrix. It has 3 rows and 1 column. So it's a column vector. While this L here, this is our L, this is our Y. The number of columns This is our row, number of row in L and number of column in L. This is a number of row in Y, number of column in Y. The number of rows, the number of columns in L must be equal to the number of rows in Y, so they are compatible for multiplication. So that means our resulting matrix will be this. So we are going to have L, Y to be equal to a 3 by 1 matrix. That's what we are going to have. So then the second one now, 5 times Y1 is 5Y1 plus 4 times Y2 plus 4Y2, then 2 over 3 times Y3 plus 2 over 3 Y3, and of course all will be equal to the right hand side, 74. So you have 3 equations. Permit me to clean this part. I only use this part to explain. So from here, this implies equation 1, equation 2, equation 3. From here we can get Y1. Our Y1 will be equal to 24 over 3, and that is equal to 8. Putting Y1 into this, you are going to have 3 into our Y1 is 8, then plus 2Y2 is equal to 40. So this will be 2Y2 is equal to 40 minus 3 times 8 is 24. So minus 24, and that is equal to 16. So our Y2 will be equal to 16 all over 2, and that will be equal to 8. That will be equal to 8. So you have that. Then again, from the third one, we are going to get our Y3. So from here, look at it, our 5 into, what is our Y1? Our Y1 is 8. Our Y1 is 8. Then plus 4Y2. 4 into our Y2 is also 8. Then plus 2 over 3 Y3 plus 2 over 3 Y3, and that is equal to what? 74. So 2 over 3 Y3 is equal to 74 minus 5 times 8 is 40. It goes to the other side, minus 40. Then 4 times 8 is 32 minus 32. 74 minus 72, that will be equal to 2. So our Y3 will be 2 divided by 2 over 3. We are making Y3 such a formula. This will be equal to 2 times 3 all over 2. This cancels out, so it's equal to 3. So our Y3 will now be equal to 3. You already have that. So our Y1 is equal to 8. Our Y2 is equal to 8. And our Y3 is equal to 3. So we have gotten that. Now, permit me to clean this part. We know our U, we know our L. Permit me to clean this very part so that we can go ahead and get. So from here, it simply means that from here, this implies that, let me write it out here, our Y will be equal to 8, 8, 3, which is Y1, Y2, and Y3. That is what our Y will be. So permit me to go into step 3. The step 3 says we should compute X. Now it will now be time to compute X. X is our main unknown. We have to compute X using Ux equals Y. Compute X using, so our step 3, compute X using Ux is equal to Y. U is a matrix, X is a vector, Y is also a vector. So now we can go ahead and do that. What is our U? Look at our U here. Our U is 1, 1, 5 over 3, 0, 1, 2, 0, 0, 1. You put it here. Then what is our X? Our X are the unknown. X1, X2, X3. You have it like this. And is equal to, what is our Y? Our Y is 8, 8, 3. As simple as that. So, beloved, I hope you are learning. So you can see that we are making progress. Permit me to clean this part so that we can have enough space to continue with what we are doing. Now, carrying out this multiplication, it goes like this. Now you start here, this carrying this out, 1 times x1, this will be x1 plus 1 times x2 plus x2, then plus 5 over 3 times x3 plus 5 over 3 x3, that will be equal to the first value there, 8. Then the second one, this is 0. 0 times x1 will be 0. 1 times x2, this will be x2 will be equal to x2 plus 2 times x3 plus 2x3, and that will be equal to the second one, which is equal to 8. This is called back substitution. This one we use the forward substitution. You can see when we're solving for the y's, we started getting values from the top. So that kind of substitution is called the forward substitution. Then if you look at this one now, 0 times x1 is 0, 0 times x2 is 0, 1 times x3 is x3. So from here, our x3 will be equal to what is the third value here is 3. So you can see now from here, we can now use our back substitution to get the value. So from here, this simply means that from here, our x3 is equal to 3 from this third equation. Then from here, we want to get our x2 plus 2x3. This will be, let me roll this line, x2 plus 2x3 is now equal to 8. What is our x2? Of course, our x3 is 3. So this will be x2 plus 2 into our x3 is 3. 3 is equal to 8. So our x2 will be equal to 8 minus 2 times 3 is 6. When it crosses to the other side, it will be minus 6. So our x2 will now be equal to 2. 8 minus 6 is 2. Then from the first equation, we are going to get our x3. So we'll come here, x1 plus x2 plus 5 over 3 x3. 5 over 3 x3 is equal to 8. So this will now be what our x1 plus what is our x2? Our x2 is 2 plus 5 over 3 into what is our x3? Our x3 is 3, and that is equal to 8. 3 will cancel 3. So this implies that our x1 will be equal to 8 here minus 2. 3 cancel 3. Then the 5 goes to that side, minus 5. So 8 minus 7 will be 1. So by implication, this means that our x1 is equal to 1, our x2 is equal to 2, and our x3 is equal to 3. Wow! What a good approach. What a satisfying approach. What a good approach. Beloved, we have come to the end of the Choleski algorithm. At the third step, we're able to compute x. Now you can see this same value if you have been watching this series, solution to the series, solution to the system of linear equation. It's a series that we started. This should be about the fourth or fifth video, if not the sixth video on this series. We solved this same problem. We have been solving this same problem right from the beginning. We have been solving this same problem from the beginning. And we use the matrix inversion method. We got x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. We use the Gaussian elimination method, we got the same result. We use the simple elimination method, we got the same result. We use the simple substitution method, we got the same result. We use the Cramer's rule, we also got the same result. Today we have used the Choleski's algorithm, and you can see that we have arrived at the same result. Beloved, this is quite interesting. Go through the video again, watch the method carefully, and see how the results have been generated. In our next class, I'll be coming up with the iterative method, the Jacobi method, and the Gaussian method. Please watch it, wait for the method, and see how the iterative method can also be used to solve a system of linear equation. Once again, I appreciate your time for today's class. Once again, please click on the notification button, share my videos and across your in your social media platforms, like my videos, and be part of those sharing knowledge across the globe. God bless you for waiting patiently to the end of this video. If you are an AI firm or you are a research institute, please consult me with your research work. I will be looking forward to partnering with you. God bless you. Enjoy the rest of the day. Bye.